If your threaded containers are filled with non-carbonated beverages or any similar liquids, the ASTM D5094 provides a good starting point to run leak tests on your products. However, after closely working with several clients over the years, we've come up with an alternative test procedure that is both efficient and non-destructive, and that can also be performed continuously during production. If you are in charge for the quality of a bottling line and you have received complaints from your distributors, or worse, from your customers, that some of your products have leaking problems, you're not alone. Producers of automotive oil, tasty fruity beverages, antibacterial gel, or even tequila are facing this very issue on a regular basis, as leaks can occur at any step of the manufacturing process. Starting with the package design, it is possible that wrong dimensions, thickness, shape, or materials have been used, failing to comply with production and transportation tolerances. A leak can also be caused by uncalibrated machines along the production line. And finally, problems could arise during handling and transportation. If you suspect that your problem is related with variation of atmospheric pressure during transportation, watch our video on the ASTM D6653 standard. Now for the fun part, let's focus on the leak testing procedure. The ASTM D5094 describes two test methods. Method A is very basic. You don't even need a vacuum chamber to test the end product on their side. The liquid has to be in contact with the closure, and then you have to wait 24 hours. Obviously, this test method cannot be considered efficient because you take the risk of getting 24 hours worth of products with possible leak issues. Now, method B is a proper packaging validation technique. However, it's not perfect. Samples have to be filled up to 1/3 of their full capacity, and dye can be added to help with leak detection. For each of the following tests, all specimens should be closed with the same torque as the final products. Place the partially filled containers upside down into the CDV vacuum chamber. Slowly increase the vacuum level to -340 millibar, or -10 inches of mercury. This vacuum level must be maintained during 10 minutes. Once the test is over, you can slowly release the vacuum back to the atmospheric pressure. Then examine the specimens to check if there is any evidence of leakage. Since method A is very slow and method B cannot be performed on end products, we suggest introducing a third method, one that we've called method RCO2. This test is non-destructive, and the samples should be final products, filled to the expected capacity, with a minimum of 5 milliliters of air volume in the headspace. Place the end products on their sides in the CDV vacuum chamber. And as in method A, the liquid has to be in contact with the closure. Increase the vacuum level up to -750 millibar or more if your container is able to withstand higher vacuum levels. Maintain the vacuum level for 15 to 60 minutes. You can adjust the testing time according to product behavior. If leaks normally appear between 5 to 20 minutes, then you can reduce the test duration to 25 minutes. Once the test is over, release the vacuum slowly to the atmospheric pressure. The Devasi method RCO2 can be performed as many times as necessary during production, ensuring that your products are leak-free. Download the PDF with detailed instructions following the link in the description. And with that, we've come to the end of this video. Until next time, have a wonderful day. Devasi, package leak testing instruments.